and action.
All right, so we've got our data. Here we go. There's our distance and there's our average time. So we just plug that into our little calculator and I got 1.697. And again, I'm only gonna go 3 past the decimal. I'm not gonna go all the way into oblivion here just because I only have 3 past the decimal there. So I wanna we're not gonna be sticklers about sig figs in this class, but we don't wanna get crazy either. And what are the units gonna be? So we're doing velocity. We've got meters up here, seconds down here. So our units are gonna be meters per second. All right, so we're in good shape. Now we have the velocity, we're getting closer. So now all we have to do is plug this into the kinetic energy formula, right? So it's gonna be kinetic energy equals 1/2 times the mass times the velocity squared. So how do we do this? 1/2. The mass we already got over here at 0.0316 kilograms. And then we're going to multiply that by the velocity squared, which is just this guy. So it's just going to be 1.697 meters per second. And then this is going to be squared. Okay, so this is the part that everybody screws up. So you want to be really careful with this. And you want to only square this term right here. Okay. So let's do this. I'm going to put this into my calculator and I'm just going to calculate 0.5 times 0.0316. Remembering that my calculator doesn't care at all about units, right? We're just putting the numbers into here. And we have to remember what the units are. Okay, and then I'm going to multiply that times 1.697 times 1.697, and it looks like I'm going to have 0.0455. Ooh, the units again. Kilograms. And when I square this meters is going to become meters squared. That second is going to become seconds squared. So I have a kilogram meter squared per second squared, which you guessed is a joule. So we're just going to put the capital J there for that first one. Okay? So not a lot of energy. It's not moving very fast at the very top. So we're only at, 4.5 tenths of a joule, so pretty low there. All right, so we've got the kinetic energy thing figured out. We're going to do the same process for the other ones, and then we're going to end up adding them together to see if we get the same thing, okay, and to see if energy really was conserved. All right.